Hello everybody. So today we're going to continue that same problem that gave us a fundamental state law for entropy and asked us to find something, like it's asking us to find different things. So this time they want us to find u as a function of t, v, and n, okay? Excuse me, okay? So what I always want us to do is start with our fundamental first and second law combined. So du equals t ds minus p dv plus mu. In fact, I don't remember if I did the first one as like a single component system or not. So I'll just say it's not a single component system. I mean, this could be a single component system hypothetically, right? If I were equal to 1 if I were equal to 1, right? If there were only one component, obviously it's a single component system. Let me say that. So because I guess I is equal 1, but like it's I to k. So what I want us to go ahead and do again is solve for this entropy, right? So that maybe we can differentiate that entropy and end up getting u from something that we differentiate, right? So ds, I'm solving for ds, is equal to du over t. And I'll actually write that as 1 over t du, just to separate out anything that might be useful to us. 1 over t du minus, or plus p over t dv plus the summation of mu I over t dn I. Right, cool. Now, what can I see? I can see that, so they want this as a function of t, v, and n, right? I know that, what this basically means when they say a function of t, v, and n, the only variables that they want to appear in our final, in whatever u is equal to, are t, v, and n, okay? So, like, what other variables are there here? So we have, and our constants, we're gonna have our constants here, right? So we're gonna have like a, b, c, and r in here, right? But they want t, v, and n, right? So, they sort of, not like they want us to get rid of this u, but we're solving for our u, right? So I can already see that if I do this, if I say that ds, del u, right? And not that, like, I'm trying to solve for this right here. If I say that at constant v and n, del s del u at constant v and n is equal to 1 over t, right? Why am I doing this? Basically, having those v and n's taken as constant when we're differentiating that, right, allows my v and my n to be left inside that whole final equation, right? I'm solving for u, right? So I'm gonna go ahead and write this over here so I can erase that and maybe give us a little bit of space. But I have t, right? Because I'm solving, I want my final answer to only have t. I mean, and I didn't even mention that. We want to have our n, our a, b, c, r, right? And then our n, v, and then we want somehow a t to be in there, right? So that's why I'm solving for this. Like, yeah, we could have had p there, but that, I mean, I could have solved for this p over t, right? But then, like, my v wouldn't be constant. Like, I would have to take u as a constant, and we're solving for u. Likewise, if I did that here, I would have to take things as constants that shouldn't be, and so on. So that's why I'm solving for 1 over t. This gives us our t here. Then we're holding v and n constant, so t, v, and n will appear in my final solution. That's just basically what I'm trying to say, okay? Now, I'm going to go ahead and erase this. I know that I have this little thing that we've solved for here. So, I can now say that del u at constant v and n of s, which is, I'm going to go ahead and distribute this out. So, nr applies to everything here, but 5 over 2 only applies to this first term, right? So I'm going to say that 5 over 2 nr ln of u minus 5 over 2 nr ln of an plus b v, right? this 5 over 2 distributes only to this first term, but nr distributes to this second term. So plus nr ln of v, right, minus nr ln of cn. Now, I can say that 1 over t is equal to this whole thing, right? Because this whole thing is simply just this, right? So 1 over t is equal to when I differentiate this whole thing, right? Now, I'm gonna look for everything that doesn't have a u in it so that I can just cancel, because we're differentiating with respect to u, right? I'm gonna look for everything that doesn't have a u in it so I can just cancel those out, because if it doesn't have a u in it and we're differentiating with respect to u, it's just a constant, right? And when you differentiate anything, when you differentiate a constant with respect to anything, it just becomes like 0, right? So this has a u, so I can't just cross that out to 0. However, this doesn't have a u, so I can say that this whole thing is equal to 0. This whole thing doesn't have a u, so the differential there is equal to 0. The differential of this whole thing is equal to 0, not the whole thing is equal to 0, rather. The differential of this, and these are all with respect to u, right, equal to 0, because we don't have u inside there. That means that I only have to differentiate this to come up with my concept for u. So I'm going to pull this whole thing out because n is a constant, r has already been given to us as a constant, that's just a number, so that's a constant, right? So 5 over 2 nr, right? Then the differential of u is, I multiply that by 1 over u, right? Times the derivative of whatever is inside the brackets, but the derivative of this with respect to u is just 1, so I don't have to worry about that. So this whole thing becomes 5 over 2 nr, the whole thing over u, right? But I'm trying to solve for this u. So to solve for this u, what I would go ahead and do is simply multiply both sides by u. This becomes u over t is equal to 5 over 2 nr, right? Then I'll multiply both sides by t. So I get that u is equal to 5 over 2 nrt, okay? And that makes sense. We're looking for, just think about it. Like, this is sort of a fundamental it's for a gas, right? Our ideal gas equation tells us that PV equals nRT. Those nRTs are sort of like a form of energy, okay? So like that sort of helps us to double check our answer. So your final answer becomes this. So this is your final answer. So U in terms of T, V, and N, let me just write it like that. U in terms of T, V, and N can be given by this, okay? All right. If anything was unclear, feel free to leave questions in the comment section. I'll do my best to answer them. And let's keep learning thermal. Thank you.